afternoon. How are you today? Welcome to today's class. In our today's class, we'll be looking at permutation question, permutation and combination. We're taking a question from Godman from exercise 16.2, question number 19. In that question, it reads, in how many ways can the letters of the word Takoradi be arranged if the two A's come next to each other? In how many ways can the letters of the word Takoradi be arranged if the two A's must come next to each other? Let's look at the solution together. Now here comes the solution. In how many ways can the letters of the word Takoradi be arranged if the two A's must come next to each other? The solution is this. The word to be arranged is Takoradi. Takoradi has 8 letters, so the cardinality of the word is 8. The cardinality simply means the number of elements or numbers or letters that make up the word Takoradi. So the cardinality of the word, that is N of W, is 8. So in how many ways can the letters of the word Takoradi be arranged if there is no condition attached, that is on a normal ground? That is 8 factorial over 2 factorial because of the A's are duplicated. So 8 factorial all over 2 factorial is equals to 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. So the 2 factorial cancels the 2 factorial. So we have 56 times 30 times 12, which is 56 times 360, which is 20,160 ways. So the word Takoradi can be arranged without any condition attached to it in 20,160 ways. In 20,160 ways. Okay? In how many ways can the same word Takoradi be arranged if the A's are separated, must be separated? If the A's must not come next to each other, in how many ways can the word be separated? So let's differentiate the A's as A1 and A2. So if we remove the words, the letters of A's from Takoradi, we have 6 letters left. So in how many ways can these 6 letters be arranged without any condition? Is 6 factorial. So let us arrange the A's around them. So let us arrange A1 around it. If we arrange A1 around the 6 letters, it has 7 possible positions to stay. It has 7 possible positions to take. So assuming it has taken 1, then the A2 has 6 possible positions to occupy, either of them. So in the diagram you can see for A1 has a possible of 7 positions marked with asterisks, 1, 2, 3, 4, 5, 6, 7 asterisks. And if A1 has taken the first asterisk position, then the remaining positions marked asterisks are meant for A2. Therefore, the arrangement, if the A's are separated, is 6 factorial times 7 times 6 divided by 2 factorial, which is 720 times 21, which gives us 15,120 ways. So if the A's must be separated, it can be arranged in 15,120 ways. 15,120 ways. Okay? In how many ways, if the A's must come next to each other, must be together, must come next to each other? Therefore, we take the A's as one letter. If they must come next to each other, that means they must be virtually taking the same position. So if we take the A's as was one letter, the number of letters that make up the word becomes 7. So the possible ways to arrange it is 7 factorial. And that 7 factorial will give us 5040 ways. Or we can say the condition of arranging the letters without any condition attached minus the number of ways of arranging the letters when the A's must be separated. That is 20,140, 20,160 minus 15,120. And that will still give us 5,040. Thank you for being part of our class today. Please do us a favor by sharing our video when you come across it, or please, if you have a comment, do where to drop it at the comment section. When you share our video, you are encouraging us. Thank you. If you want to hear from us, I remain my humble self, Mr. KK Emmanuel Ogemde. You can reach out to me through this number 080-387-46884. Thank you for being part of our class today. God bless you.